This is example 2 from lesson R.1. We are given the sets x, y, and z. X would be all of the numbers that are greater than or equal to -1. Y would be all of the numbers that are less than +2. And z would be all of the numbers that are less than -4. And we are supposed to find the intersection between sets x and y, the union between sets x and y, the intersection between sets y and z, and the intersection between sets x and z. So let's start this off and let's draw a picture of set x and y on the same number line. Okay. All right, set x would be all of the numbers greater than or equal to -1. So that's going to give us a closed circle at -1. And we are going to shade everything on the number line to the right of -1. All right, let's change colors. Set y is all of the numbers less than +2. So we'll put +2 out here. And it's just plain old less than, so this is going to get an open circle on it. And this time we're supposed to shade everything less than +2. So that's everything to the left back here, like this. Okay. All right. So the intersection between sets x and y would be all of the points that the two sets have in common. Now, in the picture, this is where I actually can see two graphs. See back here, there's no blue graph, but there is some red graph. Over here, we've got blue graph, but no red graph. And right here in the middle, I have blue graph and I have red graph. And that's where my intersection occurs. And that goes from -1 all the way out to +2. And since -1 has a dot on it, it's going to get a bracket. And the +2 has an open circle, not included here, it's going to get a parentheses. And there is the intersection between sets x and y. Now the union between sets x and y would be everywhere that the graph is shaded. So anywhere you see shaded graph at all, well, over here, remember we had no blue, but we had some red, so this is part of the union. Over here, we had no red, but we had blue, so this is part of the union. And remember, in the middle, this was the intersection between the two, so we have double shadings in there, so that should also be considered to be part of the union. And so the union between the sets x and y is going to be actually the entire number line here, and that's going to go from -infinity all the way to +infinity. Okay. All right, now we want to do the intersection between sets y and z. Okay, so let's draw on the same number line sets y and z. All right, now set y, remember, was all of the numbers that were less than +2. And that looked something like this. We are shading in the arrow back here, and then all of the number line gets shaded this way. And then for z, we're going to change colors here. All of the numbers less than -4, well, -4 is going to actually be down here. And this is also a plain old less than, so it's going to get an open circle. And we're going to shade this direction also to the left. Okay, now remember, the intersection between the two sets is where I actually physically see two graphs in the number line here. Now back here, there's no red graph, there's no green graph. This is not in the intersection. In here in the middle, I've got red graph, but no green graph above it. So this is not in the intersection. And in fact, down here, I have red graph and I have green graph. So the intersection occurs right here. And since the arrows have been filled in on both of these, that means it's going to be all the way back here to -infinity. And we're going to go all the way up to -4. Now, -4 is going to have an open circle on it and the parentheses because it's included down here, but it's not included there. To be an intersection, it has to be in both of them. All right. The last one we're going to look at is the intersection between sets X and Z. All right, so we're going to draw that picture down here. All right. Set X, we said, was all of the numbers that were greater than or equal to -1, and that looked like this right here. We put a dot at 1 and we shaded everything to the right. And then for set Z, this was everything less than -4. So we wanted to have an open circle here and shade everything to the left. All right. And so the intersection, remember, is wherever the overlap occurs. Now, over here, I have green graph but no blue graph above it. In the middle, I have no green graph and no blue graph at all. And out here, I have blue graph but no green graph. So there is nowhere on this number line where I actually have an overlap between the two sets. And that means that this one is no solution. There is nothing in the intersection between sets X and Z.